Okay, I wanted to show you today my railroad flasher that I built for my son. It's just a little simple piece of dowel rod. I know it looks terrible. I've had to repair it several times. I'll have to fix that at a later date, but it's just a piece of dowel rod with some small pieces of wood. I used a couple metal washers for the LEDs, and I just mounted it in a small plastic box from Amazon. It just snaps together. Originally, this thing would go through batteries like crazy because this button right here was one of these styles where you push it in and it stays on. And kids being kids, they leave it on and it runs the battery down. So to correct that problem, I've come up with this circuit here that will turn itself off after a set amount of time with the capacitor and resistor here, and it won't drain the battery down like it was before. This flasher here uses the classic 2 transistor oscillator. If you've dealt with electronics at all, you've seen this a million times. You know what this is. I'm not going to talk about this, but that's what is driving the lights. The timing circuit is basically a latch and a 555 timer. It's really simple. This transistor Q1 over here cuts off all current to the entire circuit. The ground on the flasher and the ground on the 555 all comes from this wire here. The only connection from the transistor here to the battery is just one wire. It doesn't go anywhere else. So when this transistor is off, current doesn't flow anywhere in the circuit. When you press the button, power goes from the positive side of the battery through the diode into this Q1, it turns it on, and it also goes to Q2 and turns it on, which sets your trigger on your 555, and that starts the monostable timer that I have set up here. When that happens, output 3 comes on, and it turns Q4 on, which turns Q3 on, which sends power back to Q1 and keeps it on until the monostable timer times out. The diode is simply just to keep the current from Q3 from going back to Q2 and re-triggering the device, which would make it not work correctly. So I know this is a lot of extra circuitry for just a small on-delay timer, but remember the whole goal here was to not eat up batteries, which it was doing before because the switch was left on. So with this setup, it uses extremely low amounts of current. We'll go ahead and pop it apart and show you real quick. The switch on this is a momentary, as you can see on the circuit. So when I let go, there's no current flowing through this wire. And right now it is off, so we'll go ahead and measure the current and show you what it's drawing. I've got it hooked up to the meter here, and we'll show you. You grab a lead. So right now we are drawing almost 1 microamp of current with it off, and I'll go ahead and I'll push the button, and you see as it's running, it's drawing about 15 milliamps on average. So just some quick math. 1 microamp, I'm going to be generous and say this battery is good for 500 milliamp hours. So 0.5 divided by 1 microamp gives you about 500,000 hours. Divided by 24, it's about 20,000 days. Divided by 365, it's, 57 years. The battery's obviously not going to last that long, but it's going to last a lot longer than with a standard switch where it runs all the time and it's drawing 15 milliamps constantly. So that's my little circuit. I just wanted to show that real quick. Thank you for watching. and carry on.